Stanford University.
All right, well, welcome to Stanford CS 193P, winner of 2015. This is lecture number 2. Apologize up front for my terrible voice. We're going to try and get through this as best we can today. Our topics are twofold. We're going to continue the calculator demo that we started in last lecture. And then we're going to have some slides about this model view controller object-oriented design pattern that we're going to use in everything we do when we build applications in this class. All right, so let's get started with that demo. Again, here's a slide with a summary of kind of the important things we're going to talk about. You don't need to read those in advance here. It's more for reference. My slides in general, I post them. It's mostly intended to almost be note-taking for you, to be able to go back and try and figure out, whoa, what did he talk about that day? Oh, yeah, what's important, etc. So my slides do tend to be a little bit dense. I tend to put a little more on them than just bullet items. But that's because I want you to be able to look back and kind of get just a little bit more depth to remind yourself what I talked about. Okay? All right, so this demo, if you'll remember last time where we left off, we had gotten the keypad fully working, all right? And we were talking a little bit about properties and instance variables and how we had to initialize them. And someone asked a question right at the end of lecture, perfect timing, what about the little outlet that we dragged out, that display UI label exclamation point? How come we didn't have to make that equal to something to start? And that's where this demo is going to pick up, okay?
Okay, well, let's dive back into this demonstration where we left off, which was this line of code here. And we had just talked about the fact that we have to initialize all of our variables in a class, in any class. And so that's why we need this equals false here. We wanted the equal false too, but we needed it. And yet it didn't seem like we needed one here. And why was that? Well, it turns out that this right here, even though it doesn't quite look like one, is an optional. And optionals automatically get equal nil given to you. So you don't have to actually put the equals nil here. So that's why, so this one is getting initialized. It's just being done automatically for you. But let's talk about the look of this thing. It's got this exclamation point here. And if it were an optional, you'd be used to it having a question mark. For example, when we look at this optional right here, current title, you see it's string question mark, not exclamation point, question mark. So what's the difference between a question mark and an exclamation point here? And the answer is it makes no difference to the actual type. It's still an optional whose value here could be a UI label. But it matters on the usage of it. And this is purely just kind of compiler helping you out thing here. But if we look, when I change this to a question mark, you see that some errors appear down here. So let's click on one of these errors, like this one, and you can see the error is that UI label question mark does not have a member name text. In other words, you can't send text to a UI label question mark, which is what this is. And that makes sense because a UI label question mark is an optional, and obviously optional doesn't respond to text. UI labels do, but optionals don't. So why are we getting this error now when we weren't getting it before? And how do we get rid of this error? Well, we could certainly get rid of this error by just putting an exclamation point here. That would unwrap this optional. And now this would be a UI label right here. We can send it text. And we could do the same thing up here. We can unwrap it there, and we can unwrap it there. And that gets rid of all our errors. But this is kind of an interesting property in that even though it's not initialized at the very beginning of our class's creation, it starts out as nil, not set. As soon as this user interface over here gets loaded up by this view controller, then this gets wired up, right? So that gets wired up, and this is set, and then it's set forever. So it's really kind of would be sad if we actually, every time we used it, had to unwrap it all the time. So these kind of properties that get set very early, maybe not right at creation like this one, but they get set very early and then they stay set all the time. You can, instead of putting a question mark in their declaration, we're talking about their declaration here, you can put an exclamation point. And what that says is, this is just an optional, but always automatically unwrap it so that you don't have to put this exclamation point in here. So if I take this exclamation point out, you can see it's not generating any errors, and it's still going to unwrap this display and turn it into a UI label. And it's still going to crash your program if for some reason the display were nil. If you tried to execute this code, it would be impossible because this is the button sending this, so the button wouldn't be here if this hadn't gotten already loaded up and set. But if somehow you had some place in your controller where you were accessing display before this UI got loaded, it would crash because it is unwrapping this. It's just that you don't have to put the exclamation point. It's kind of like auto exclamation point. And this is called an implicitly unwrapped optional. Okay, implicitly unwrapped optional. And it's really only useful for this kind of property that's set very early and then stays set forever. So it's kind of syntactic sugar, really. Okay, so let's move on to the next button in our UI right here, which is going to be an enter button. Now, our calculator does not have an equals sign, so you're probably used to calculators where you say 6 plus 3, and then when you hit equals, it shows you the result. This calculator, a little more like a scientific calculator, has an enter key. And so instead, you put the numbers you want to add or divide or multiply or whatever onto a stack, and then when you press the operation keys, it pulls them off the stack. So that looks like this: 6 enter 3 times, or 6 enter 3 enter times. So the times is going to pull the 6 and the 3 off the stack. Or you could even go 6 enter 5 enter 4 enter, and then go times plus, and that would multiply the top two on the stack and then add the last one on. So we need an enter key here for our calculator. Now I'm going to create that enter key in a way that's actually going to cause a problem for me in a moment, but I want to show you how to resolve that very problem. So I'm going to create this enter key by copying and pasting this digit key right here. And I'm just going to put it in here. Notice how I'm lining these blue lines up absolutely perfectly. I don't want them to be, you know, like it's lined up with that one, but not that one, or vice versa. I want them perfectly lined up because later I'm going to spread these out over the whole UI. And if I haven't lined these up just absolutely perfectly, then Xcode's not going to quite know what I want here in terms of the relationship between these. All right, so we don't want a 3 on here. We want to have a enter symbol. So I'm going to go up here to special characters. So this is on in most Mac applications. You can go to the edit menu and get special characters. And I'm going to search for this one actually. I think it's called a return. Yeah, and these are just Unicode characters right here. And so I want this one that looks like kind of like a return key or an enter key. So I have this, and I'm going to use the same mechanism we used before, which is control drag. So I'm just going to control drag out here, and we're creating an action, of course, because we want this button to send us a message. I'm going to call it enter, because that's what it is, the enter key. Now, one thing that's different about this one, if you remember when we wired this action up, we had the button who was sending it as an argument, and we don't want that this time because there's only one enter key. We don't really need to talk back to the enter key, so we're going to say none right here. So it also doesn't really matter about this type because we're not going to have an argument, so it doesn't matter what this type is. So let's connect that. You can see right here we have enter, and it has no arguments. Now, what are we going to do inside enter? Well, the main thing we need to do is put whatever number is in this display up here, okay, onto our internal stack. So we're going to need an internal stack in a moment here. Another thing we might want to do is set users in the middle of typing a number to false, because we might have been typing a number, but as soon as we hit enter, we're putting it on the stack. Next time we type a digit, we're going to be starting a new number. All right, so we'll call that user is in the middle of typing a number false there. Now, let's go ahead and actually run this and see how this is working, because there's going to be a little problem here. I'm just going to run this. All right, so let's try 8, enter. Oh, well, what's that? Not good. 6, enter. Well, it's kind of working because and after we press enter, the user is in the middle of typing number, starts over, so that's good. but I had no intention for this to be showing up on the end of my display, this little enter key. So what the heck is going on there? Why is that happening? So let's take a look here. The problem here has to do with the messages being sent. So when we wired this up, that's good. We got enter. The problem is that button also sends a pen digit. And that's because we copied and pasted this 3, remember? And the 3 sends a pen digit. And so when we copy and pasted it, now this one sends a pen digit. So it sends both. Okay, it's sending 2. Now, that's a common mistake to make. You didn't really think about that when you copy and paste it. How do we fix this? Well, if you right-click, so I'm going to right-click on this button, you'll get this window that comes up, and it shows you all the connections from this UI element to your code. And you can see here, both append digit and enter are connected. Now the great thing is I can just click this little X right here, and it'll take this connection away. So now I only have enter. So now if I go back here, see, it's not sending append digit, it is sending enter. And you can do this right-clicking for anything, like we can even do it for our label up here. We can see there's the display connection that we have right here. So yeah, don't forget right-click to disconnect things. Now, if you forget about this and you don't do it, or maybe you have it wired up to some thing that you changed. For example, if we had accidentally put an argument here to enter, if we had made it do the sending button trick, kind of like this, you can't just say, oh, okay, and I'll fix that, I'll just delete that, because that would not work, because enter with an argument is actually a different message than enter with no argument. And so if you just deleted that, when you run your program, it would crash, and it would say, couldn't send message enter colon when you touch this button, because enter colon means enter with an argument, only for the purpose of the storyboard. We don't say enter colon in our code. That's just something in the storyboard here. So if that happens, you need to right-click on here, disconnect the enter colon that happened in there, and then you just re-control drag. And when you re-control drag, it's nice. It will kind of let you try and grab onto something. So it's easy to reconnect. Okay. All right, so now we want to actually implement enter here. We want to implement the guts of it. And so we're going to need another property here, which is going to be that internal stack that these numbers are going to go on. And so that's going to be a var, just like this var up here that we created. And I'm going to call it operand stack. That's a good name for it. And it's going to have a type. Its type is going to be an array. And just like in other languages like Java, when you create an array type, you have to specify what kind of thing is in the array. And so I'm going to put doubles in my array. And that's even, you might say, oh, well, we can't enter doubles because these are all integers basically. But if I were to say 3 enter 6 divide, I'd get 0.5, so then a double would appear. So that's why I'm going to use double. Now, you can see that we've got this error up here again. It says stored property operator in stack does not have initial value. So we have to give this initial value. So I'm going to give it an initial value of an empty array. And so now you're seeing for the first time how you actually create an instance of a class or of a data type. And you do that just by specifying the type name and then these parentheses. Now, we haven't talked about initializers. A class or a data structure can have multiple initializers. Some of them might have arguments in here. But most, if it's possible, will allow you to create them with no arguments. And in the case of an array, it's very obvious what to do. No arguments, it just creates an empty array with no elements in it. Now, one thing I want to talk about is this right here, this type. This is kind of annoying that we have to type this and then we just type it right again. And the answer is we don't have to do that, because in Swift is very strongly typed. In other words, all the variables, all the properties are strongly typed, but there's also a lot of type inference. So Swift can infer this type in the exact same way that digit had no type and it inferred it from here. operand stack, we don't have to specify the type, and it can infer it from here. And if we option click on operand stack, you'll see, indeed, it's figured out that that's an array of double. And in fact, putting the type in here is considered bad form. If it can be inferred, you should let it infer. So, for example, this bool up here, we shouldn't have that either, because false and true can only be bool values. So we're going to take that off as well. Okay. So now, in our operand stack right here, what do we want to do with it? Well, when we press enter, we just want to append. So append, this is actually the first time we're sending an actual message to an object. It looks just like when we accessed a property, right? The dot. And it's just the name of the method that we're trying to invoke in arrays. It's an array method right here called append. And you can see the argument says new element :t. This :t means it has to be of this type, the type of thing that's in the array. So this has to be a double. So that's kind of a problem, because really what I want to append onto my stack is what's up here in this display text. I like to say something along the lines of display.text. Okay, but what type is this? Okay, what type is display.text? No, that's not string. That is an optional. Okay, remember that display.text is an optional. So we can unwrap it, even though that's not going to solve the problem. This is still a string, and you're still seeing an error here. It's saying string is not convertible to double because you're supposed to be putting doubles in this array and putting string. So we have a problem here. We have to somehow convert this string into a double so we can put it on this stack. I'm going to use this opportunity to show you another feature, which are called computed properties. So I'm going to create another property, display value, and it's going to be a double. And what I want this to be equal to is I always want it to be whatever's in this display converted to a double. Okay, and I want to be able to set it or get it. So I want to be able to get the value of this double. I also want to be able to set it as a double and have it turned into text. Well, that kind of property really is tied to some data somewhere else. So I don't ever want to set it equal to some initial value or something. Really, I want it to always be calculated. And we can do that. Instead of saying equal something, you just put curly braces after. And you say get, and we say set. Okay, and inside here, we're going to compute the value of this, which is we're going to convert this display text to a double. And then inside here, someone said display value equals something, and we're going to somehow compute, or not really compute it, but we're going to decide what code we need to put that number that they tried to set the display value to in here. Okay, so let's do the set side first. It's actually a little simpler. Inside this set, there's a magic variable called new value. It's not purple for some reason, but new value, and this is the new value. So if someone says somewhere in our code display value equals 5, this new value will have the 5. And so all I really want to do here is say display text equals the new value, but again, of course, this is an optional string. You can't set it to a double because display value equals 5. This new value is going to be a double. But we know how to convert something to a string by using \parentheses. Okay, this is the same thing we did when we printed out our digit up here. We just use the \parentheses. It tries to convert this thing inside here, which is a double, into a string, and doubles know how to do that to themselves. And so bingo, we've got our display text in there. That's all that's necessary. Also, every time someone sets this display value, then we're clearly not in the middle of typing a number anymore. All right, so we can certainly say that. Right, makes sense. All right, what about the getting? Now, in the getting, all we have to do is return this display value. So to do something to calculate what this display value is here, and then return it. Now, this one, I'm not going to take the time to go through the details here, and actually I've made an extra credit item that you can do, which requires you to figure out what I'm going to type here using the documentation, but I'm not going to explain it here. But I'm going to use a class that's called an NSNumberFormatter. I'm actually going to create one. Then I'm going to use a method on it called number from string, and I'm going to give it this string, which is the display values text, unwrapped, of course. The result is actually optional, so I'm going to unwrap that. And then I'm going to get the double value of the thing that I get back. Number gives me this kind of generic number, so I'm going to take it and turn it into a double. So there we go. So you can go in the Xcode and look at that later if you want. But suffice it to say, we now have a property display value that when we set it and get it is going to be setting and getting it as a string here. So that is really convenient, especially for right here where we want to say display value. Okay, so this is a double, no problem. We're appending that onto the operand stack. So let's println our operand stack here. Just so, and we can do the same thing here, operand stack. Okay, and this works because operand stack is an array, and arrays know how to turn themselves into strings. You'll see how they do that in the console in a moment here. So let's go ahead and see if our application is actually putting things on our stack properly here. All right, so let's try here. Let's try 56, enter, and look, the operand stack is 56, that's good. 7, enter. All right, 56 and 7. So you can see that arrays turn themselves into strings by doing open square bracket, and then they turn each of their elements into strings and separated by commas. Another one. Okay, so this is good. So we got our operand stack building here. So all we need to do is have some times and plus and minus buttons, etc. I'm going to put them right here that will operate on these items on the stack. So if I pressed plus right now, it would pull the 7 and the 8 off the stack, add them together, it would be 15, show that 15 here, and it actually would put the 15 back on the stack, so then we'd have 56 and 15 on our stack, and then we could maybe plus those together if we wanted by hitting plus again. All right. Okay, so how are we going to do that? Well, we need to make our buttons here, and I'm going to make the buttons again by copying and pasting a digit button, but this time I know about that problem, so right off the bat I'm going to right click on it and disconnect append digit. Okay, so now this button sends no messages yet anyway, and then we can put a title on here. So here I'm going to have all my operation buttons use mathematical symbols. So if we go down here to math symbols, see there's a bunch of math symbols here. So let's do times right here first. I'm going to put a times right there, and we can wire it up. I'm just going to hold down Control and drag out here. We're going to call this action method operate. And because I'm going to have multiple operation buttons and they're all going to send operate, just like I did with append digit, I am going to use the sender. So I'm going to be very careful to change this any object to be button. Okay, do not forget that. Okay, so action, we are going to have a sender UI button, call it operate. Here it is. Nice message doing operate. We can copy and paste this button now, right? We got this one, so let's copy and paste and make some more of these. Start out with 4 of them, let's say. Okay, let's get back our special characters here. All right, so let's make this one be divide. Let's make this one be plus. Make this one be minus. All right. So now we got these buttons, and they're all sending, if we look at this here, they're all sending operate. Okay, luckily they're not sending anything except operate, so that's good. And when they send operate, we're going to figure out which one is sending it by same exact way we did above. We're going to say what is the sender's current title, and we're going to unwrap it. So operation here is going to be a string. And it's going to tell us the title of the button so we know which one to use there. Now, I'm going to show you a control flow operator here in Swift that's very powerful, much more powerful than this operator is in other languages, and also very, very important to Swift. Now, I'm only going to show you the simplest usage of it here, but you're going to see on Monday's demonstration and later in the quarter how important this operator is. But it's switch. Okay, And switch looks like switch in other languages like C. You switch on something. In this case, I'm going to switch on this string. This is a string. And then you just specify the case of each thing. So, for example, here I have a case. Let's do the multiply. All right, so we got multiply case right here. And then we just put the code that we want here for multiply. And we can do that for all the other cases here. So let's copy and paste. And we'll do this be our divide case. And we'll have this be our plus case. And we'll have this be our, oops, let me use this, make sure we're using the same guard here, minus case. Okay, yeah, you be a little careful here. You know, this minus is slightly different from this minus, which might be slightly different than the minus you type with the keyboard. So when you're putting the symbols here, you want to use exactly the same symbols here in your case. Now, one thing about switch on Swift, though, is it absolutely requires that you have every case covered. Now, since this is a string, I obviously can't have case of every single string in the universe. That's almost infinite. But luckily, there you can say default and just break out of the switch. Okay, that means if it's not one of these cases, by default, just break out of the switch. You could put code here as well, but breaking out of it is what we want to do in our case. Now, in here, we're just going to put the code for multiply. So what do we need to do for multiply? For the moment, I'm going to comment this out. I'm going to use command slash, which is a really nice feature. You do command slash. And then command slash again to uncomment. So it's good for commenting out a block of code real quick because I just want to focus on times. Now, anytime I press any operator, I probably want to give the user an automatic enter. That's so that 6 enter 3 enter times is the same as 6 enter 3 times. Okay, so 6 enter 3 times is going to do an automatic enter on that 3. Because obviously I intend to have 6 and 3 be multiplied in that case. For all of these operations, I'm going to say if the user is in the middle of typing a number, then hit enter for me right here. Okay, so what do we need to do in the specific case of times? Well, really we just want to set our display value. Remember, we have our nice display value down here, and we can do setting as well as getting. So I'm going to set that display value up here equal to multiplying the top 2 things on the stack. So I can actually remove something off our stack. We're representing our stack as an array. Of course, you see our stack is an array. And so a stack is something you push things on, you pop things off. And with an array, we're just going to add something at the end to push something on, and then we'll just remove it from the end to pop it off. So there's a nice array. This is an array, right, after and stack. So there's a nice method called remove last. And if we option click on remove last, you'll see here that it removes an element from the end of the array. Now, it does require count greater than 0. So if our array were empty, if our operand stack were empty, this would crash our program. So let's put a little protective thing here. If the operand stacks, there's a nice property here called count on that. If it's greater than or equal to 2, actually, because multiply takes 2 operands, so there better be 2 things on this stack, then we can do this. And so we're going to multiply that by remove the next one. Okay, so here we're just taking the last 2 things off of this stack by removing them from the end of the array and just assigning it to the display value. And we probably also want to do an enter here because if I go 6 enter 3 times, well, I want to then be able to say 9 plus and have it add on to the 6 times 3. So we want an automatic enter here as well. Okay, so that's pretty much all we need to do here. Let's go ahead and run this. See how this works. And so 6 enter, or 3 enter, 6 enter. Now we've got them both on the stack times, and you can see we put our 18 here. We also put it back on the stack. And we can say 5 times. That put a 5 on the stack, and then multiplied them, took it off. So that's working nicely. Now, what about our other buttons here? We're going to make those work. So let's do that. Now, they do very similar thing here. So one temptation would be to just copy here, let's uncomment these out, and then just paste it repeatedly. So put it there, put it there, put it there, and then just change this times in here, to plus, for example, on this one. But this is pretty messy code. Look at all this incredible amount of duplicated code in here. We really probably wouldn't want to write our code like this. People would think we were terrible programmers, I think, if we did that. Really, what would be nice is if we had could write some kind of function. Maybe we could call it perform operation or something like that. And if the argument to that function, remember that arguments have names, right? Here's the name, and then we have a type. If the argument were something which basically was this little operation in here, okay, or some sort of function that would do this operation. So if this could be some kind of function, that'd be cool. And then maybe we could take this code out of here, put it in here. Oops, let's call it perform, not preform, perform operation. Put it in here, and instead of doing, multiply here, let's go ahead and we could do this operation somehow like this. Maybe operation, call it like a function with 2 arguments here. Okay, that would be cool because we'd be sharing, this check, we'd be sharing this enter, we'd be sharing the removal of the operand, we'd be sharing setting the display value, we'd be kind of sharing a lot of code here. And then up here, if we could just do something like perform operation and somehow specify multiply as the operation we wanted to do here. And then we wouldn't need all this stuff here, right? So this would be cool. Now, can we do this? Well, yes, the answer is we can. And so types, functions, can be types in Swift, just like any other type. So, we have a double here. Whoops, the double, that's a double, that's a type. You can also have a function type. So how do you specify a function type? Well, multiply, or whatever function I'm going to perform here, this is a function that takes 2 doubles as arguments, and it returns a double. So I can just say, I want operation to be a function that takes 2 doubles and returns a double. So I can just specify that right here. This is a type. Okay, so the type, it's the type of this argument right here. In fact, you can option click on it and say, yeah, that type is double, takes 2 doubles and returns a double. So it's just as simple as that. So all we need now is a function here called multiply that takes 2 doubles and returns a double that does multiplication. So we could go down here and say, okay, func multiply, and I'll have op1, which is a double, and op2, a double, and it returns a double, and it's just return op1 times op2. Okay, and that worked great. I'm going to comment these back out again so we can see if this actually works. But there's no errors here, right? It seems to work. Multiply seems to be a function that takes a 2 double and returns a double, and that's what this argument here is, and I'm passing it along. It should all work, so let's give it a try. So here we go. This is 6, enter, 54 times. And sure enough, it's working. It's doing that multiplication. Works great. And so what about all of our other cases here? Well, we would just need to take this same piece of code right here and put it for all of them. And of course, we'd need a divide method, so we'd have to come down here and copy and paste that and make divide. Wait a second. This is starting to be just as bad as we had before, having to make all these extra functions, multiply and divide and all that. Well, it turns out it's so common to pass functions as arguments in Swift that it allows you to put a function like multiply right in here without having to create a separate function like this. And all you do is you just pick it up. So I'm just going to cut that from down here. I'm going to paste it right in here. Now, the only thing you have to change syntactically when you do that is this curly brace, okay? Instead of being after the declaration of the arguments and the return value, it needs to be before. And so you move the curly brace before, and then where the curly brace was, you're going to put in, the word in. And so that allows us to just, sorry, I'm going to comment these out again so we can get rid of our errors. And we can get rid of function multiply down here. So that allows me to just put that multiply right in here, right in line, right as the argument to this function. And this seems kind of wacky for those of you who have not used programming languages that allow this kind of things. They're called closures. It just basically allows you to put a function right in there. And this, okay, it looks okay. And then we could certainly, now we could copy and paste this and put it here, here and change this and put it here and change this. But it can be even better than this. So we know that Swift is really good at something called type inference, where it can kind of figure out the type of something from the context. And it can do the same thing here, because it's looking at perform operation. It knows you're calling perform operation. It knows this argument is a function that takes two doubles and returns a double. So you really don't have to specify all the types in here, because it knows all this. So you can actually get rid of all these type declarations right here, even the return. And again, see, no warnings, no errors. It knows that this has to be a double and this has to be a double, because it knows you're calling perform operation. So it knows the argument to that is like that. Okay, and you can even make this look a little nicer. We could move this all up onto one line. Really makes that nice for readability here. But we can actually do even better than this, because Swift knows that perform operations argument returns something. You don't need this return key if your whole implementation is just an expression like this return keyword. You don't need that keyword because it knows this is going to return something. So if this is just an expression, it's going to return it. Okay, so that looks nice. But it's even better than that, because Swift does not force you to name these two arguments. If you don't name them, it will use the names $0 and $1, and then if you have more arguments, $2, $3, $4, such that you don't even need this. Okay, so this is a function right here. It takes two doubles, $0 and $1, and returns a double. Now, Swift knows that they're doubles because it knows you're passing them to perform operation. If you were passing this to some other function that took a different kind of function as an argument, these types might be different. But in this case, it knows that that's what it is, and it knows that it returns one. So it knows it's going to return what this calculation is. All right. Now, one more cool syntactic thing you can do is if you have a function like perform operation, and it has an argument, which is a function, like operation here. If this argument is the last argument, okay, so if I had other arguments before it, and this was the last argument, then you can move the function outside the parentheses. So other arguments, if there were other arguments before, they would go in here. But this last argument, which is this operation, gets to go outside the parentheses. And if there are no other arguments, if this is the only argument, you can actually get rid of that. Okay? So we've gotten down to incredibly concise language here, and we can do this exact same deal, of course, with these other form operations. We just need to change the math in here. This one, we had a little careful with the order of operations here. We want to do this because we put the thing that we're dividing by on the stack last, and that's the first thing that comes off the stack. And same thing here, actually, with subtraction, minus $0. Okay, so this is our entire operate, and you can see that it's incredibly concise, very readable. Times is clearly doing this function, and very extensible. If we want to add more functions, we just one-liners here to put more of these binary functions that have 2 operands. So let's go ahead and make sure this is all working. All right, so 6, enter, 5 times, that's 30, that's good. How about 47 plus, 77, excellent. How about 2 divide, 38.5, we're seeing the floating point number there working. You can see the stack is doing all the right thing. Okay, makes sense. Now I'm going to do one more thing here, which is to add another operation. This is going to be a slightly different operation. So I'm going to copy and paste these operation buttons here. Again, I'm going to make sure they're lined up really nice with as many of these blue lines as I can get. I'm actually going to leave these buttons here because you're going to need them for your homework. But we're going to change this button right down here to be a different operator, which is going to be square root, which is right here. It's the square root operator. All right. And so I'm going to go back here to do square root, and it's just another case, right? Case square root. And maybe I should just be able to use this same mechanism, right? Let's see if that works. Paste that in there. And instead of this subtraction here, let's use the built-in function in Swift to do square root called square root. And we did $0. Looks good. Yeah, we're ready to go. It should just work, right? Oh wait, what's going on here? We have some sort of error. Why? What's the problem? I don't understand. Let's take a look at this. Now, this error is a little hard to understand, but basically what it's saying is that you're calling perform operation here with an argument, which is a function that only takes one argument. Because Swift looks here and it sees that it's only using $0, so this is a one argument function. This whole curly brace thing is a function that takes one argument. Well, perform operation takes a function that has 2 arguments. So that's a mismatch. That doesn't work. So how can we fix this? Well, actually, believe it or not, we can just make a copy of perform operation of another method, same name. This one's going to have different arguments. It's going to have an argument, which is a function that only takes one double and returns a double. And then inside here, obviously, we don't need to pull 2 things off the stack, just one. And obviously, we only need to check to make sure there's one thing on the stack. And look, all errors, warnings gone. Okay, Swift automatically figured out that this perform operation must be this one because this is a function that only has one argument, and so it matched it up with this version of it. So in Swift, you can have functions with the same name. They can, as long as they have different arguments, and Swift will automatically pick the right one if it can. There are some times when it's just like, I can't really tell which one you mean, and it will certainly complain in that case. But most of the time, it's going to be able to tell from the types involved what's going on. So let's go ahead and run this one again real quick. 36 square root. Looks like it's working. 9 times square root. Excellent. Okay. All right. So the last thing I'm going to do here is work on the layout of these buttons. So that's all I'm going to do for the code. You can see that we really didn't have to write that much code to make this work, and we got to do a lot of stuff in our UI here. So let's go ahead and make it so these buttons spread out, because right now you see all the space is wasted right here, and on an iPhone in portrait mode the whole bottom space is wasted, and in an iPhone on landscape mode this whole side is going to be wasted. So I really want these buttons much bigger and stretching out. Now when you do something like that, you have to think a little bit of kind of what your strategy is going to be. You can't just kind of brute force start, control dragging between things and trying to set up the horizontal spacing and maybe line up them, maybe make them the equal width and height. Oh my gosh, you'd be control dragging all day long doing that. So I'm not going to use control drag to do this. I'm going to use these buttons down here, which are kind of bulk auto layout buttons. Let's go ahead and use the whole screen here, document outline. So what is it going to be my strategy? Well, my strategy is I'm going to make a perfect grid here. So I almost have one, except for there's one missing here. So I'm actually going to take a button, copy and paste it. Okay, just kind of be a dummy button here actually with no title. I'm going to right click on it also because I don't want it sending a pen digit or anything else. So it's not going to send any messages. But it's just a dummy, so I'm kind of using a little bit of brains over brawn here to do this perfect grid. Now if I have this perfect grid, then if I had a rule where all these buttons had to be the same size, and they all had the same spacing between their neighbors, not just between each other, but the same spacing to this edge and the same spacing to this top edge, okay? If I had a rule like that, then they would get big, and of course this same spacing from this edge to this edge and this edge to this edge. If it's all exactly the same, which I'll make it be whatever this is, whatever the blue dashed blue lines gave me, if that was the same, then they would all have to spread out. Okay, they'd get bigger, but they'd all stay the same size because I'm going to make a rule that they have to be the same size. But they would move out to this edge so that this nearest neighbor would be the same, this distance would be the same as this distance. So that's my strategy. I'm going to try to do that. Now, to make that work, all these buttons need to know who their nearest neighbor is. Well, these all know their nearest neighbor here, the other buttons, because I made sure I used dashed blue lines when I dragged them in there. So that's what kind of teaches them the nearest neighbor. And I'm also going to make sure that the entire grid knows that the left edge and just under the label there are the nearest neighbor. So now it knows on the top the nearest neighbor is the label, and on the left is this edge. And it's going to pick this edge as the nearest neighbor for these buttons and the bottom edge, because that's all there is. There's nothing else out here, so it kind of that's the only neighbor there is. It's going to pick those. So now that I've kind of used my dash blue lines, it makes this all quite easy. Now if you don't use the dash blue lines, or if you kind of make some mistakes, then this is not going to work. This strategy won't work. And I've made doing this part of this demonstration be extra credit. And so if you can't get it, don't worry about it too much. Just keep all your buttons in the upper left corner here, and that's fine. But if you want to give this a try, the key is to use the dash blue lines to make a perfect grid. Make sure that you set the nearest neighbors here by dragging the whole grid to make blue lines appear on the sides. And then we're going to set these rules in bulk, and we do that with these buttons down here. So there's this button right here, the leftmost button, and it lets you set things like lining up leading edges or the tops or the centers. And you could imagine there might be a way to do this by doing that, but I'm not going to use that strategy. My strategy is to just make them the same size and make the spacing between them be the same. But I bet there's probably a way to do it by lining up their centers or something like that too. So I'm not going to use this one. The next one over right here is the one that has the things I want. And so you can see that it allows you to make all the buttons equal width and height. Okay, not width and height, that fixes them at a certain width and height. This means that they can be any width and height they want, but they all have to be the same width and height, all these buttons. Of course, I have these all selected, by the way. If you don't have them selected, it doesn't make any sense. And then up here, you can see there's spacing to nearest neighbor. So this is where I'm going to set that spacing between all of these to be the same. And you can see that it's put 8 here. That's because when I did the dashed lines to the top, 8 seems to be kind of a standard number of points between elements. These are all multiple because some of these buttons, their nearest neighbor is way over here, and it's huge, right? The bottom or their right. But all these buttons, the thing on top, whether it's another button or whether it's this label, all of them happen to be this 8 points right here. So I want all these to be 8. So I'm just going to turn this bar on right here, which says, yes, please enforce and make the rule that all of these are 8 points from their nearest neighbor to the top, and also 8 to the left, 8 to the right, and 8 to the bottom. You really want to make sure these beams are on. If these beams are off, even if there's a number here, then it's not going to add this rule. So we want it to add this rule. So this adds up to 87 different rules. All these equal widths and heights, and all these sparing neighbors. So if you don't have 87 in here, if it says 100 and something, whatever, and probably you don't have everything lined up right, because it only takes 87 constraints to express all these rules. All right. Now, when I click this add 87 constraints, it's going to add these rules to all these buttons. And watch what happens. So I get all kinds of, first these blue lines are showing me the rules. Okay, a lot of them are saying here that things are equal widths and heights. That's what these little equals rules means. But there's also tiny little I-beams right up here that are showing the spacing to nearest neighbor. And also look, there's a lot of yellow here. This yellow, remember, means, yeah, there's constraints on these, but they're not actually where they're supposed to be based on those rules. So we really want to move them all to be in their proper spaces based on these rules. That's what these dashed yellow lines mean. So we can do the same thing to do that we did at the beginning with the label on the top, which is go to our document outline here in the lower left corner. Okay, here's our document outline. When we last saw it, it only had this one label in there. And now we got all these buttons added. You can see they're all selected, and they're all selected here as well. And we've got this little yellow thing up here. Now, if this is red, okay, if you do all this and this thing is red, well, that means that you've got not just warnings that your constraints aren't in the right place, but you've got errors, usually conflicting constraints, where you've asked auto layout to enforce two rules that conflict with each other. So if you get to that red, this is not going to work. So you'll want to start over, and I'll show you in a minute how you can restart over if things are not going your way. But if it's yellow, that just means things are in the wrong place, so no problem. We click the yellow. Here's all the things that are in the wrong place. This is all the buttons. You can see they highlight as I mouse over them. And you can really pick on any one of them to fix this, because there's a nice little switch here called Apply to All Views and Containers. You don't have to click on each one and have it frame update to the proper thing. You can just click Apply to All Views and Container, and it's going to move the frame of all the buttons to fix the fact that they're in the wrong place based on their rules. So let's try that. I'm going to hit this button right here, Fix Misplacement, and it moved them all. There's no more yellow. There's no auto layout issues. Okay, all looks good here. Close our document outline. If we zoom out, we can see, wow, it spread them all out, okay, because it's obeying those rules I gave it. Okay, so let's now run this on some devices here and see what this looks like. So sure enough, on an iPhone 6, which is a pretty tall device, it's made them, you know, kind of tall and thin. So hopefully it still works. 5, enter. 69, 8, 7, 4 times, and 5 divide, maybe square root, something like that. It all seems to be working. Now, not only is it working here in this portrait mode, tall and thin, but if we go over here to this, we can rotate the device. Okay, so I'm going to rotate it left and right. I'm actually going to use the command keys to do this. So there we rotated it right, and we can see now it made the buttons spread out into this new location. Everything still works. Okay? And we can rotate back using command keys here, and it looks good in either orientation. And in fact, it can look good on other devices as well. So let's go over here, and instead of doing an iPhone 6, let's try it on an iPhone 4S. Okay, so I'm just going to switch the simulator here. Let's run that. Now the iPhone 4S, you can see, is a little shorter. It's not quite as tall. A little lower resolution, obviously, but it relayed out the buttons to look good in that case too. So there's 9 times 9 divided by 8, square root, etc. And same thing here. We can rotate, and it'll look good this one as well. Okay. Alrighty, so the last thing I just want to talk about briefly is if you try this extra credit and it doesn't work for you, it gets all messed up, you can kind of start over by clicking on this and using the third button over here from the right. And this allows you to reset your constraints. And you can see the top section here is the selected views. I don't have any selected here, so this wouldn't do anything right now. But the bottom is all views and container. And I kind of recommend going down here to all views container and clearing the constraints entirely. Reset to suggested constraints are going to try and make some sense of your dashed lines, but if it's not working, your dash lines are off anyway. So you can just go here and clear constraints, and I'll clear them all. Now that's going to clear not just your buttons, but also it's going to clear your label. So you'll have to reposition your label with blue lines, and then use Control Drag to set your top space and all that stuff. You know, if your buttons are really huge, they got really huge, but they're not in the right place, you can actually change the size of all your buttons in the Utilities window. If you go to the size inspector right here, that's this one, you can actually type in the width and heights you want the buttons to be. You can make them smaller again, which, you know, maybe 64 by 64. That might make them easier to re-drag them into position so that the blue lines are working. And don't forget the very important the blue line dragging, which is you want to take the whole grid and drag it so that it's sitting underneath your label. If you have a problem dragging the whole grid underneath your label, sometimes it's a good idea. Clear all your constraints, kind of move your buttons out of the way, just kind of move them down to the bottom here. And then just for your label, do reset to suggested constraints. This top one, selective use reset suggested constraints, because that will work for the label if you move it into position, as long as the buttons aren't too close and it thinks that you know, those buttons are near neighbors or something. And sometimes resetting it to suggested constraints will make it so that that bottom edge of your UI label will be attainable when you drag your buttons into position. But again, not to worry too much about this auto layout stuff. It's extra credit in assignment 1. It's not going to be extra credit in assignment 2. So you're eventually going to have to do it. And I'm going to be giving a big lecture on this in a couple of weeks on auto layout, because really I've only just shown you just kind of what it can do. I haven't really taught you how to do auto layout in particular. But auto layout is very important because, you know, we work in the square area and we want our UIs to work on all kinds of different devices. So that's why we're starting off from the very start with some experience with it. All right, so that is it. Now, later today, in this lecture, I'm going to give you a talk about this design paradigm called Model View Controller. And we actually designed our calculator kind of poorly, because all of this code here is really nothing to do with UI. This is all calculator brain, calculator engine code. And this really wants to be in a different object, and that's what MVC is all about. And so I'll give a little talk about MVC later today, and then on Monday we're going to fix our calculator to obey MVC and be a proper citizen in the iOS world where all apps need to obey Model View Controller paradigm.
So let's try and understand. I mean, half of you said that you already know MVC or you've seen it somewhere else, so this is going to be mostly a review, but the other half of you, this will hopefully give you an idea of what MVC is all about. So MVC is basically a mechanism where we divide up all the objects in our application into one of these 3 camps, okay? So the 3 camps, on the left there you see the model. So the model camp is going to be all the objects that are what your application does. So for our calculator, it calculates, okay? That's what it does. So all the parts where we're doing perform operation and all that stuff, that's all kind of calculator stuff. That should be in a calculator object somewhere else. It shouldn't be in our controller, okay? And then the second camp is the controller. So the controller controls how the model is presented on screen. And the view is the minions, the classes that the controller is going to use, kind of like the building blocks, the Lincoln logs. I don't know, maybe that's before all of your time, but you know, the things we're going to do to build our UI, we're going to use in the view. So the stuff that's in the view is pretty generic. Okay, generic UI elements. The stuff in the controller is very specific to how your UI works, and the stuff in the model is completely independent of how your UI works. Okay? So doing MVC right is about knowing where things go, but also about how to communicate between these 3 camps. And so I'm going to try and summarize how the communication works between these camps, and I've used road markings. You see the double yellow line and then the dashed white line, so that's like you're driving in your car. Try to use them as I have an image for how this communication happens, where it's allowed, where it's not allowed. Okay? So let's talk about the controller talking to the model. Okay? Well, going from that side of the road over to the model side is a dashed white line. In other words, you can head right across there. Probably want to look before you go, but you can go right across. Okay? The controller has to know everything about the model, and it has to have complete ability to talk to the model, use its public API as much as it wants, because the controller's job is to present the model to the user using its view as its minions. So it has to have this access. So that's full unrestricted access the controller has talking to the model. This is a one-way error, one-way arrow from the controller to the model. And similarly, from the controller to the view is also unlimited communication, because the controller is responsible for using its own minions. The view is the controller's minions to lay out the user interface and all that stuff. So the controller can do anything it wants. I've put that little green word outlet up there because when we have a property of a controller that points into the view, we call it an outlet. Okay, and you're going to see that in the demo on Wednesday. I'm going to say, oh, let's create an outlet from our controller to our view so our controller can talk to its view. All right? What about this communication? Model to view? Never. And why is that? 100% obvious. The model is completely UI independent. So there's absolutely no way it could talk to a view object or anyone in that camp, because the view objects are fundamentally UI objects. They're kind of generic, but they're still fundamentally UI objects. Similarly, since the view objects are kind of generic, they can't be talking to any specific model. They need a controller to interpret a model for them. Okay? So there's never any communication this way. That's why it's a double yellow line. That's why these lines are red. That's why there's fire. Okay? Never go across that line, ever. What about the view talking back to the controller? You got these generic view objects like buttons. Can they talk to the controller? Well, yes, they can, but they have to be careful because the view objects are generic. So they can't really know much about the controller. So they can only communicate back to the controller in a blind way, where they don't know the class or the thing they're talking to, and in a structured way, a way where we all agree we're going to communicate this way between the view and the controller. So what's an example of a structured way? Well, one is called target action. So the controller basically drops a target on itself, and then it hands out an action, which is like an arrow, to the view, and says to the view, okay, when you do what you do, like you're a button and someone touches you, or you're a slider and someone moves you, send me that action. Okay? So in this way, the generic button or slider is communicating back to the controller. It has no idea that it's a card game controller or a space game controller. It doesn't know what kind of controller it is. All it knows is that when something happens in itself, boom, it sends a message to the target. So that's a blind, simple, structured way for the view to communicate with the controller. Okay? But what about more complicated ways? Sometimes the view, things are happening in the view that are somewhat complicated, and the controller needs to be informed of what's going on, synchronizing what's happening. And one way to think about this is these words I put up here, will, should, and did. When the view is kind of like, let's say I'm a scroll view and I'm scrolling around, and I want to let the controller, somebody, know that the user just did scroll. Okay? Or the user puts down the touch and is about to scroll, I want to let the controller know the user will be scrolling. Okay? Or the user puts the touch down and the scroll view wants to know, should I allow the user to scroll here? Is that allowed? All those things, the scroll view itself might not have enough logic to know the answer to those questions. So what it does is it delegates the authority to answer those questions to some other object. Now, it doesn't know the class of that object. All it knows is that other object can answer these questions: will, should, did, this, that, or the other thing, like should allow scrolling, did scroll to point, things like that. So those are the kind of methods you're going to see in these delegate protocols. Now, I know that CS106 A and B do not teach protocols. The word program. How many people know what the word protocol means in object-oriented programming? Okay, see, very few of you. So I will be teaching that. A protocol is just a blind way to talk to another object. You're going to, when I teach you, you're going to be like, oh yeah, I know what that is. So we didn't really call it protocol or whatever. But that's how we do delegation, okay, this blind communication. Also, another important thing is that views should not own the data that they're displaying. They should not own it. In other words, it shouldn't be a property inside of them where that's the truth. of that data. And the easiest example for this is all the songs in your iPod on your iPhone or your iPad, right? You might have 10,000 songs in there. So if you have some kind of generic list view in your view, you can't transfer all 10,000 songs to its instance variables and expect it to hold 10,000 songs so it can list through it. A, that would be inefficient. And B, that information, those 10,000 songs, belongs where? In the model. Okay, because your song database is a model. It has nothing to do with UI. It's just a list of songs and artists and albums and all that. It's in the model. Some controller has to look at that database and tell a view how to display all those songs. Okay, so we need that communication to happen here. And the view is displaying some sort of list, and you're touching down and you're flicking on the list and trying to see more songs. How does that communication happen? And the answer is, we have another special kind of delegate, which we call a data source. Now, the data source doesn't do the will, did, should. It's going to be asking questions like count, like how many songs are there? And the controller looks in the model, 10,000. Response to the view, there's 10,000. The view makes space internally for 10,000 things. It doesn't know what they are, moves the scroll bar indicator a little bit so that you know where it is. And then you start scrolling, flipping through it, and it starts sending the message to the controller, give me the data at line 150, next 10 items. You see what I mean? And then you flick down some more. Now it's saying 250, 10 more items. And so the controller is going back to the model and saying, give me more data, and it's providing it to the view in this blind way. So see how the view is getting data from the model through the controller in this kind of blind, structured way. Okay? That makes sense to everybody? So data source is just a kind of delegate. It's a specific kind of delegate for getting data. So you're going to see that there are classes in iOS that have a data source, and they usually also have a delegate. Most sophisticated classes in iOS have a delegate, the will, did, should kind of things. Some of them have a data source. It depends on whether they're showing a lot of data or not. Now, simple data, like if I had a view, if I invented a view for my card game called playing card view, and it just has a suit and a rank, okay, we're not going to do count data at for just suit and rank. We are going to set those properties. And so the view then would have that data set in it, but it wouldn't be owning it, right? The model would still be owning the suit and rank. The view is just getting that data to present it. Okay, so simple data we might transfer to the view, but it's merely for it to display it. Okay, this all adds up to the controller's job being to interpret and format the model data for the view. That's the controller's job. And when we do our demo, I'm going to be remarking like, oh, see, I'm writing this code. This is to make the controller perform its job, which is to take the model data and put it in using its view minions, put it on screen. Okay, that's what the controller does. What about this communication? Can the model talk to the controller? Again, obviously that's verboten because the model knows nothing about UI, so it couldn't possibly talk to a UI object like the controller. But sometimes things change in the model, and the controller needs to know about it. Okay, data changes, a database changes, or the model is some network database, and somebody changes something on the network, and it changes, and the controller needs to find out. So how do we do that communication? We do that using kind of a radio station model. Okay? So the model, a radio station concept, the model will use this concept to essentially broadcast information to anyone who's interested. Okay? And the mechanisms for doing this in iOS are called notification and key value observing, KVO we call it. And so the model can just say, oh, anytime something changes in my model, I'm just going to broadcast on my radio station. And then the controller simply tunes into that radio station. And it can find out things are changing. And when it finds out something changes, it's going to communicate via its green arrow to the model and say, OK, give me that data that changed. Right? Does that make sense? So towards the end of the quarter, we'll start seeing how to do notification to find out, for example, if the data in a database changes. We'll get a notification. The UI can then, controller can then go talk to the model to get the new info. Okay? Some people have asked, can a view tune into the radio station? They probably could, but you probably wouldn't want to do that. That would probably be a violation of MVC. All right, so we do this. We have all this nice communication and all these rules, and we can imagine building something simple using this. But what if we want to build a big complicated app, an app that has multiple screens on our iPhone or on an iPad? It's got, 3 or 4 different areas on screen where things are happening. How do we do that? Well, we're essentially going to combine multiple MVCs, okay? Because an MVC can use as part of its view another MVC, okay? So an MVC, an entire MVC, can be one of the minions of some bigger MVC, okay? And by doing that and cascading it down, we can build more and more complicated applications. So an example of this is you might have your calendar app, and it's showing you the entire year. And you click on a month, and now it shows you a month view. Well, a month view looks a lot different than a year view. A month view just has all the days and maybe some circle that tells you where you have an appointment on a day. And then maybe you click on a day, and now you get a day view, okay? And the day is showing you the hours and what all your appointments are. And you click on an appointment, now you get an appointment view, and it's showing the detail of where you're going and when it is, et cetera, okay? Well, each of those views, the year view, the month view, the day view, and the appointment view are their own MVCs, okay? But you can see how the last 3, okay, are used as essentially a minion of the top level view, the year view, to show more detail, okay? So the year view, you click on a month, it's going to use the month view MVC to show more detail. So it's part of its view, okay? So you see this also in iOS with tab bar controllers, right? You have the tab bar at the bottom might have 4 or 5 things you can choose. Well, there's some MVC at the top has 4 pointers to 4 minions, which are the 4 MVCs that are each going to appear in a tab bar, okay? And we'll be doing that, for example, in assignment number 2 or 3, where we'll be making a tab bar, and you're going to have to do multiple MVCs, okay? So that basically results in a picture that looks kind of like this, all right? Where you got this MVC, and you see the purple one that's like underneath the word together there, and it points to 3 other MVCs outside of its view thing, okay? That's how we're going to build it. So that might be a tab bar controller, and those might be the 3 tabs. Okay, and each one is its own little MVC, completely independent, operates on its own, doesn't even know. It's a generic, usable, reusable view-like thing at this point. Doesn't even know that it's in a tab bar. Okay, it just knows it's supposed to do whatever it does. And so it's modular in that way. You can also see that there's no communication between there's no other arrows except for some of the models. You see some of the models are communicating with each other. A big application might have a single shared model, or the models might be split off into pieces to be used by sub-MVCs, okay? But that's the only kind of communication you have there. All other communication is either the structured view communication we saw in MVC, or it's using MVCs as part of the view of another MVC. Any question about that? So we definitely don't want to be having designs that look like this, okay? Where everybody's talking to everybody, we can't tell who's talking to what. It's just impossible to debug a program like this, and it doesn't scale. You can't build really big programs this way. It just becomes impossible to know how touching anything would break everything, right? So we're definitely not going to be doing that. All right, so that's MVC, and like I said, on Monday we'll apply MVC to our calculator. So what's coming up? I always try to get to this slide every lecture. Sometimes I forget, but it's posted in the slides. It says tomorrow is Friday. No, day after tomorrow is Friday. And people who are watching on iTunes U, these Friday sections will not be on iTunes U, so don't go looking for them. Only the normal Monday, Wednesday lectures will be on iTunes U. But for Stanford students, Friday we have this debugger section we talked about. And then next Monday, your reading assignment is going to be due. In other words, you should be done with that reading assignment before the start of Monday's lecture. And I'm going to assign you another reading assignment. It might be your only other reading assignment. Perhaps there'll be a reassignment 3, but it won't be any more than that. And then on Wednesday, I'm really going to dive into Swift and Foundation. I'm going to talk a little bit about the Objective-C legacy. And then your assignment 1 is going to be due a week from today. It's been posted for you. And your assignment 2 is going to go out next Wednesday and be due the Wednesday after that, just for a little bit of advanced planning for all of you. Okay? Any other questions? Okay, thank you.
For more, please visit us at stanford.edu.